talk about decision trees and a little ensemble assignment that I have. So these are a few use cases that we had to do, and we were given a few hints. So let's start. The first one is using gradient boosting. So let's go to the collab. So this is the using gradient boosting machine. So as you can see, we just have to import a few necessary libraries, and then this is the class that we have. And then here we're generating synthetic data, synthetic random data with a few features and noise, and then using the gradient boosting machine. So we're giving a few hyperparameters to that, and then fitting that particular train and test to that machine, and then making the predictions. And then this is the evaluation part, and then we're also doing the plotting. So as you can see, the actual ones are the ones in blue and the predicted ones are in the orange. So it is kind of very close to each other. So this is about gradient boosting machine. So moving on to the next one, so let's look at random forest. So it's an ensembling method for like classification and then also regression. So here the first thing we're doing is just taking all of the necessary libraries that we need, like the data sets, and then after that model selection metrics, and then after that we're just taking the decision tree. So defining a few requisite functionalities, and then this is the random forest method that we have, like the init, fit, and predict, and also the calculating the accuracy. So we're taking these columns. So this is the diabetes data set. We're taking it from this particular URL, so we don't have it anywhere in our GitHub. But yeah, so since we already have the URL, we'll be able to replicate it directly, and then just doing some exploratory analysis on that particular data set, making the XY columns, and then dividing that into test and train, as you can see. And then here we have the random forest model, and then making the accuracy and testing the accuracy, and then also the precision recall. So this is a kind of a very simple method, I would say, using like random forest. And then moving ahead, let's go to AdaBoost. Let me just close these. So this is like using the AdaBoost algorithm. So as usual, we have just to import all the necessary libraries. Then here we just have a function to calculate the accuracy. So skipping all of this. So this is where our actual algorithm comes into the picture. Then we have something like in the gradient descent we also have like forward propagation and also backward propagation. This is a prediction method. So this is the class that we have for AdaBoost. That was for logistic regression. Then for the accuracy, the error, and then prediction weightage, all of that, all of the methods that we need. And then this is where we load the data set. So we're doing it on diabetes data set. So yeah, I have the data set in collab. If you want, in GitHub, if you want to directly download that, just get it here and then probably run the collab. So displaying the head and then distributing that into X and Y, and just splitting that into test and train. And also after that we're just calling the AdaBoost function, and based on that, like the base estimator is like we're building it on top of logistic regression, and then we're doing the fitting, and then after that we're just testing out the accuracies. So the precision is 0.46. That's kind of less, but yeah, this is the ROC curve. So this is about AdaBoost. And then we'll continue on the part 2.